What if the sun suddenly disappeared? And I don't mean just dimmed or, slowly burned out over billions of years. What if it completely vanished in a split second? Today, we are diving into this explainer to tackle the ultimate physics thought experiment and see exactly what it reveals about our universe.
So let's imagine the exact second the sun just blips out of existence. Here on Earth, absolutely nothing happens. Literally, we wouldn't even know it occurred. People would still be walking their dogs, reading a book in the park, enjoying the warm sunshine for exactly 8 minutes and 20 seconds. It's this beautifully eerie concept, right? A cosmic delay where the entire planet is just existing on borrowed time, totally oblivious to the fact that our life source has already been erased.
Now, you might be wondering, why the delay? Well, it all comes down to the hard limits of physics. The average distance between the Earth and the Sun is about 149.6 million kilometers. And sure, light travels unbelievably fast, roughly 299,792 kilometers per second, but that is still a finite speed. It's not instantaneous. It takes that light a little over 8 minutes to cross that massive void of space. So, those lost photons emitted by the dying sun are still hurtling towards us, keeping us in this temporary state of blissful ignorance.
Okay, just to make sure we're getting the physics right, we need to clarify our parameters here. There are really two ways to look at this problem. Scenario 1, the sun stops emitting light but keeps its mass. In that case, we'd stay perfectly in orbit. Or, Scenario 2, the sun completely vanishes, losing both its light and its mass instantly. Now, while the sudden disappearance of mass is physically impossible according to known mechanisms, Scenario 2 is absolutely the much more fascinating thought experiment, and that's the one we're tackling today. We lose the light and, crucially, we lose the gravity.
Now, here is a truly mind-bending rule of general relativity. You might think that even if the light is delayed, the loss of gravity would be felt immediately, right? Well, wrong. Changes in a gravitational field do not transmit instantaneously. Just like light, gravitational influence travels at the exact same cosmic speed limit. That means, for those 8 minutes and 20 seconds, the Earth's orbit wouldn't change at all. We would continue perfectly circling a ghost star that is already gone, held flawlessly in place by a gravitational phantom.
But then, the clock hits 8 minutes and 20 seconds. The information finally reaches Earth, and that gravitational tether completely snaps. See, Earth relies on the sun's immense gravity, which accounts for over 99.8% of all the mass in our entire solar system to stay in its nearly circular orbit. Once that's gone, Earth's own inertia just takes over. We would immediately fly off tangentially, moving in a straight line out into the dark, freezing interstellar space. And we wouldn't be the only ones. From Mercury all the way to the outer gas giants, every single planet would retain its kinetic energy and just scatter in straight lines like cosmic marbles.
At that exact same moment, our trajectory changes. The visual reality hits us. The sky goes pitch black. The sun simply shuts off like a light bulb. But it wouldn't just be the sun. The moon would vanish from view as well, because all that brilliant moonlight we see is literally just reflected sunlight. The other planets in our solar system? Gone. Invisible to the naked eye for the exact same reason. We'd just be left looking up at a permanent, eerie night sky, illuminated only by distant, alien stars.
So, here's the question you're probably asking yourself right now. Will Earth freeze immediately? We've all seen the sci-fi movies, right? In almost every apocalyptic scenario, the moment the heat source goes out, the world turns to solid ice in a matter of seconds. Everyone freezes mid-step. But does the actual science of our planet back that up?
The answer is an emphatic no. We would absolutely not turn into a giant snowball in seconds. It's actually one of the biggest misconceptions about this entire scenario. Yes, our planetary thermal equilibrium is instantly destroyed, and the surface would start cooling relatively quickly as we radiate all that infrared energy out into space. But we have some pretty massive built-in defenses.
The reality is, Earth possesses these massive thermal batteries. Our oceans and our atmosphere hold tremendous amounts of thermal energy. On top of that, we have geothermal heat constantly radiating from the Earth's inner core, and cloud cover that basically acts like a giant trapping blanket. Because of all these factors, instead of an instant cinematic flash freeze, we are looking at a slow, creeping chill. It would take quite a bit of time for the global surface temperature to actually plummet down to truly extreme levels.
And this thermal defense creates a really surprising dynamic, especially with our oceans. First, the surface of the oceans would gradually freeze over. But here's the trick. Ice is actually a terrible conductor of heat compared to liquid water. That means this thick layer of surface ice would begin to act as an incredible insulating blanket. Because of this insulation, combined with that geothermal heat venting from the ocean floor, The deep sea would remain entirely liquid for a very, very long time.
Watching this unfold chronologically is honestly like watching a slow-burn nightmare. At 0 minutes, the sun vanishes. At 8 minutes and 20 seconds, sudden darkness hits and we officially become a rogue planet. Within hours and days, the surface cools drastically and critically, photosynthesis completely halts. Fast forward to weeks and months, and the global ecology and all surface food production utterly collapse. Over years and decades, Earth transitions fully into a dark, frozen world quietly traveling the galaxy.
This creates a really stark contrast for life on our planet. On the surface, it's a total catastrophe. Without photosynthesis, the process plants, algae, and certain microorganisms use to turn sunlight into chemical energy, the global primary food production simply ceases. The surface food chains break entirely. But down in the deep sea, life might just carry on, completely oblivious to the tragedy happening up above.
How is that even possible? It's through this fascinating process called chemosynthesis. At the absolute bottom of our oceans, clustered around hydrothermal vents, there are entire microbial ecosystems that don't rely on the sun whatsoever. They use the chemical energy erupting from the Earth's crust to survive. These deep-sea communities could continue living and thriving, perfectly insulated beneath miles of ice, completely unaware that our star even vanished from the sky.
But what about us? In a world without natural light, without agriculture, or a steady climate, modern surface society would obviously face a catastrophic collapse. The loss of that immense solar energy flux is just way too great. However, human survival isn't theoretically impossible. To survive this, humanity would have to retreat deep underground. Would require massive, highly advanced infrastructure. We're talking relying entirely on nuclear and geothermal energy, utilizing massive artificial lighting systems for controlled indoor agriculture, and depending on perfectly sealed closed-loop water and air recycling systems.
And those underground habitats would have to remain perfectly sealed, because over extreme stretches of time, as the planet continues to endlessly radiate its heat away into the void, something truly bizarre happens. The atmosphere itself will eventually freeze. First, the water vapor turns to ice. Then, as temperatures plunge incredibly close to absolute zero over vast timescales, even the very atmospheric gases we breathe, like nitrogen and oxygen, would condense and freeze, falling to the ground like a strange alien snow.
As we drift out of our solar neighborhood, we actually wouldn't be entirely alone. Even though the moon's light would have gone out at the exact same time ours did, the gravitational bond between the Earth and the moon remains perfectly intact. So this beautifully eerie cinematic reality takes shape, a dark, frozen Earth and its dark, frozen moon, permanently locked in a gravitational dance, silently wandering together through the infinite blackness of interstellar space.
It really makes you step back and appreciate our place in the universe, doesn't it? The sun is just so much more than a bright light in the daytime sky. It is the fundamental energy engine driving our climate, our biology, and the very gravitational architecture that gives our world stability. Which leaves us with this final thought to ponder. If our fragile existence is entirely tethered to the relentless energy of a single localized star, is humanity truly prepared, technologically or psychologically, to one day outlive it?